Hi everybody. So I am working on problem number 7 from section 3.6, and basically what's going on is you have a square or a rectangle inscribed in the equation y is equal to 16 minus x squared, and our goal is to write the area function as a function of x, where x is the distance along the x-axis. And the first thing, which I'm going to do out of order, is I'm going to talk about the domain. So the smallest x can be is just a smidge to the right of 0. And the largest x can be is just a smidge to the left of 4. Because if it was 4, you wouldn't have a rectangle, you'd have a line. And if it was 0, you'd have a rectangle, not a rectangle, but a vertical line. So the first thing we need to think about is this ordered pair. This ordered pair that's on the graph, and it's the edge of the rectangle, has coordinates x, and then you know that the y is equal to 16 minus x squared. And so what happens is that y is really 16 minus x squared. So whatever your x value is, you plug it in to this expression, and you end up getting your y value. Okay, so now area of a rectangle is length times width. Well, I'm going to treat w, the width of this rectangle, as x. You could call it its length. It doesn't really make that big of a difference. So if this is the length, if this is the width, if the width is x, then the length of the rectangle, which is going to be this piece, is 16 minus x squared. So it's the height. You can think of it as base times height, either way. Well, anyways, so length is 16 minus x squared times x, which is your length times your width. Now, if you distribute your x, your area formula is now 16 times x minus x cubed. And we've talked a bit about the domain. Now, we've got the formula. The question that is of some interest is, what is the area when will the area be the largest? In other words, what x value produces the largest area? So what I did was I started off and I said, let's just try some values, and we'll actually end up having to do a calculator response here. But I started off with x equals 2, and I plugged in 2 for x, and I got 32 minus 8, which is 24 square units. All right, so I tried x equals 3, and I got 16 times 3, which is 48. 3 cubed is 27, and so I have 48 minus 27 is 21 square units. I said, okay, let's try x equals 1. And again, plugging in 1, I got 15 square units. So clearly, my answer is somewhere in this world, around the 2's and the 3's. So I said, okay, let's try 2.5. And when I tried 2.5, I ended up getting 16 times 2.5 minus 2.5 raised to the third, which I punched in the old handy-dandy graphing calculator, and I got 24.375 square units. Now, there is actually a way to do this in calculus, and I'll just do a real brief description. You take the derivative of this, and we talked briefly about the derivative. And the way the derivative works is you bring this exponent down and multiply it by 16, and then you drop that exponent down by 1. Well, anything to the 0 power is just 1, so it's 1 times 16. Bring this 3 down in front, and bring that exponent down by 1, so now we have 3x squared. And you set this equal to 0, and the reason you set it equal to 0 is when a function's at its maximum, it's at its highest point, the tangent of it is 0, and that's the slope of the tangent. Well, this is the algebra to it, and we get somewhere around 2.309, which almost fits what we said. So it works out to be 4 squared roots of 3 over 3. And if you ask about that, I can show you how to do it. But I'm not that worried about this. This I won't ask on a test. But I do want you to see how to do it on a calculator. So I'm going to pull out a handy-dandy graphing calculator, and I'm going to show you how this works. So what we do is the following. We're going to take, and we're going to go to turn on our calculator. We're going to go to our y equals. And what we're going to do is we're going to type in 16x minus x raised to the third power, and we hit enter. Okay. Now that's our function that we got. So I'm going to go ahead and hit zoom standard. Okay, now if you look at this and realize that this doesn't match this, that's okay. What we're looking for is the highest value in between 0 and 4. This is the function 16x minus x cubed. It's the blend of x times 16 minus x squared, so it's not going to look the same. So what we're going to do is I'm going to change my window, and I'm going to change my y max to, say, 30. I'm just going to hit enter. All right, so this is where, right here is where our maximum that we need is going to be. So I need to hit the second key, the trace key, and I'm going to find the maximum. And I need to get the cursor to the left-hand side of the hill, and I hit enter. And then I'm going to move to the right-hand side of the hill, and I'm going to hit enter. And you see, it's looking for the high point in between these two, what I would say is eyes. And I'm going to hit enter, and it's going to say the maximum is at 2.309, which is what we found through our calculus approach. But you can do this using your handy-dandy graphing calculator. Okay? All right. What is the area, by the way? It's 24.63 square units, approximately. All right. Hope that helps. I'll talk to you later. Bye.